Hi guys, in this video I'm going to show you how to make a scatter plot with different symbols for levels of a factor variable, and then draw a smooth Lowess curve for each level of that factor variable on the same plot. And then we'll run a regression model for each level of that factor variable, and all this we'll be able to visualize on one scatter plot. So let's go ahead and introduce the data. This is the motor trend cars data, which is packed with the base package. So as you can see, we get the model number of the cars, we get the miles per gallon, the number of cylinders, it's 2, 4, 6, or 8, and the displacement of the engine, and a lot of other things. But I'm going to be interested in these three, okay? And what I'm interested in is this miles per gallon. I want to see if displacement, or the size of the engine, is a good predictor of miles per gallon. So first thing to do is to plot y versus x, right? So MPG versus displacement, and see if the scatter plot could start telling us a story. And we see already that there seems to be some kind of negative relationship, but it might actually be curved. But actually what I'm more interested in is looking at this scatter plot here at different levels of this variable here, cylinders. And what do I mean by that? Well, let's make the same plot, except let's change the symbols to be levels of the number of cylinders of the car. So as you can see, it's split out here. Here are 4-cylinder engines, the X's, 6-cylinder engines, and 8-cylinder engines. Okay? Let's also make the colors change accordingly, and that will make it even cooler and more easy to decipher between those three. So as we could see here, we got a cool effect going on. Okay, so now that we have this plot, let's add Lowess curves for each grouping. So we want a Lowess curve that would probably say something like this. A Lowess curve. Lowess curve is like a smooth curve, right? And something like this. Okay? Let's let the algorithm, the Lowess algorithm, figure this out. Okay, so I'm just going to do this in a loop. I, N, C, 4, 6, 8. Those are the three levels of cylinder, CIL. Okay, sorry. For I, N, I didn't close this parenthesis. And what I want to do is I want to add lines, Lowess, empty cars. I give the Y and the X here, just like I did for the scatter plot. Okay, and let's change it to a dotted line, and let's make the colors equivalent to the cylinder we're looking at. Okay, and actually if we left it like this, it would give us the overall Lowess, which would be something like this. And we don't want that. We want 3 separate Lowesses, one for 4, one for 6, and one for 8. So let me go back in here and say empty cars. sil equals I, so whatever the level of I is, and the same thing for displacement. Empty cars sil equals, let me make my screen bigger, I. Okay, and let me close the loop, hit enter, and as we can see here, we got the Lowess curves, right? So this kind of gives us a little idea about the relationships of these points taken as groups, 3 separate groups, but all visualizing on one plot. So a little bit of just fun programming and using R, and a little bit of understanding points and being able to visualize them. Okay, so now the next step and last step is let's run a linear regression for each one of these groups and also plot the 3 lines. Okay, so this first group, which is for 4-cylinder cars, looks like it's well approximated by a simple linear regression, right? It's a linear relationship. So let's run that. We'll call that M4 for the 4 cylinders. LM. Empty cars. $ MPG. And our predictor is displacement. Excuse me, buddy. Actually, my cat's getting in the way of the screen and trying to walk all over the keyboard. Come on, buddy. You don't need to actually write out the whole statement like that, because there's an argument called data in LM. So let's do it that way. Okay. Data equals empty cars. And let's subset this for sil equal to 4. I think this should do it. Okay. Yes. Okay, and let's just plot that and make sure that that works. Use AB line to plot that. So plot M4, and also let's choose the color to be the same as the color for these guys. So that blue, and that's, you can write blue or you can call it with the number 4, and LTY equal to 1. That should give us a solid line. Let's see. And there you go. Okay, so we got the line, the simple linear regression, or the least squares regression line for the first group of data here. Okay, and it's color coded, right? A legend might be good to do at some point. I think that'll make the video too lengthy, but let's do, here it looks like a linear regression is not a good idea. Perhaps a quadratic regression. So let's run that. This is for the 6-cylinder engines. LM, MPG. We're still trying to predict MPG with displacement. And I said quadratic, so let's add the quadratic term using this I functionality. Data equals empty cars, and the subset this time is for 6-cylinder engines. Okay, and so we're here. Now, plotting this curve is a little bit tricky, and I'm not sure if I remember exactly how to do this, but I believe we can do it with lines. M6 might do it. AB line predict M6 Okay, let's leave that off. And let's do M8, and let's come back to that. This M8 looks like maybe a simple linear regression might be fitting. You could argue that simple linear regression is not the best choice for this grouping, but the point here is just to be able to plot this stuff, not to really focus too much on the regression. Okay, so M8, color equals 8, comma, LTY equals 1. Okay, so we got this curve. We just need this curve over here for this guy. So what we could do is we could do something in the order of length, empty cars, and we could say sil equals 4. So let's see what the length is. 32. So we could do something in the order of plot sequence, and we could do it from 0 to 500, perhaps 0 to 500. Length equals 32. That's why I needed that 32. And I need to go back and take this t off. That's my x, and my y will be predict M6, right? And type equals line. Let's see if this works. Let's also do the color here while we're at it. Color is going to be 4. Okay, let's see if this works. The length is different. Okay. Okay. Well, that's not the point here. Plotting a curved line, I'll do in a subsequent video. But as you can see here, although this got a little messy, the point here is that we can plot different symbols on one graphic device, different colors, so we can identify groupings. Here the groupings were real clear. Then we could add Lowess curves to start seeing or understanding the nature of the relationship, whether it's linear, curved, and then we could start talking about what kind of model we can use to kind of try to explain miles per gallon with displacement given the grouping 4-cylinder, 6-cylinder, or 8. Okay, and that itself is a big topic. You could spend a lot of time and a lot of research and come to slightly different conclusions. But the point here was to just apply a very simple type of regression for each one of these and to plot it all on one graphic device and see the results. And so just to finish this off and get some closure, let me rerun this regression model for these guys, the 6-cylinder engines, just making it linear so we can just really get the point of this kind of tutorial instead of focusing too much on the quadratic. I'll do another video on the quadratic stuff. So I just converted that to a simple linear regression. The color was 6, kind of almost purple, and LTY is 1. And so there we go. So we got all three groupings have a Lowess curve and the simple linear regression line, color coded, symbol coded, and all that's left to do is to add a title here and maybe clean up these axis labels, which I believe I have shown you how to do in another video. Okay, so I hope this was a little helpful, just a little R fun, some useful stuff, and again, to actually focus on the model building is a whole set of lectures on its own. So hope I just just expose you a little bit to what's possible. Okay, so thanks for watching. Till next time, have a great day, and make sure to subscribe.